The goal of CTCR in this project is to study an efficient process for the conversion of ethylene glycol into polyethylene glycol, which will be later used by the University of Alicante as a solvent for PHA extraction. The synthesis of polyethylene glycol from ethylene glycol is not straightforward, but consists of several intermediate steps. Therefore, it is necessary to determine the optimal conditions for each reaction intermediate. To assure the performance of each step, the reaction intermediates are characterized by gas chromatography. These techniques allows the quantification of the conversion and purity of each product. In addition, the molecular weight of polyethylene glycol is determined by size exclusion chromatography. First, the sample of ethylene glycol supplied by enzymicals needs to be purified by fractional distillation. During this process, the water contained in the sample is completely removed. Then, by increasing the vacuum and temperature conditions, pure ethylene glycol is obtained, leaving the remaining impurities in the flask. Once the purity of ethylene glycol is checked by gas chromatography, the product can be used in the first step of the synthetic route. Two-chloroethanol is obtained by selective chlorination of one of the alcohol groups of ethylene glycol. To obtain the best reaction yields, several parameters such as reagent concentrations, reaction times, and temperatures have been evaluated. Once the reaction is finished, 2-chloroethanol is extracted from the aqueous phase and purified by distillation to remove volatile compounds. After characterization by gas chromatography, the product is ready to use in the next step. Because the following reaction intermediate is a gas product, the reaction is carried out in a stainless steel reactor that withstands high pressures. A small fraction of this gas product is dissolved in methanol to be characterized by gas chromatography. Finally, the polyethylene glycol synthesis is carried out by ring opening polymerization of epoxides. To obtain the desired molecular weight, it is important to control not only the temperature and time of the reaction, but also the concentration of the reactants. This reaction is performed under mild conditions, and after a specific time, a white solid appears. The amount of precipitate increases quickly. The resulting polyethylene glycol is characterized by size exclusion chromatography to confirm its purity and molecular weight. This polyethylene glycol is sent to the University of Alicante, where they will use it as a solvent for PHA extraction.